guys, are there any questions on any of the assignments so far? So what we're looking at today is 6.32. So we started 6.3 last week, and we're finishing it up today. Now, the inverse property with logarithms is one of the things that's really nice with them. And it states, one of them states that log base b of b to the x is equal to x. So whenever the base and what's inside the logarithm here are the exact same, they will simplify out to 1. So whatever the exponent is will be what this is equal to. We can say the same thing with b to the log base b. When we put a power and the base of the log are the exact same, they simplify out, so what's inside the logarithm will be what it's equal to. They undo each other. So when we look at an example of this, it'll make a little more sense. So if we look at the first one here, A, we have 10 to the log of 4. Now, whenever there's not a base with a logarithm, it's what we call the common log. And the base is understood to be 10. For logs, L-O-G, whenever the base is not written, it's understood to be 10. So for this here, since we have 10 to the log base 10, these are the same, this is actually going to simplify out, leaving us with what's inside the logarithm, which is 4. So 10 to the log base, or 10 of 4, is just 4. That's all we have to do for this here. Let's look at the next one here. Log base 5 of 25 to the x. Now, if we had this as log base 5 of 5, then it would simplify out. Log base 5 of 5 would simplify. Now, can we rewrite 25 as 5 to a power? It would be what? 5 squared. 5 to the 2. Now, powers of powers multiply. So our 2 times x is just going to give us 5 to the 2 x. Now, just like with the last one, log base 5 of 5, this is going to simplify. It's going to undo itself, leaving us with what? 2x. So log base 5 of 25 to the x simplifies to 2x. Questions on this here? Now the next one we're seeing here is we want to simplify 10 to the log of 18. Well, the unwritten base for this here is, so what would 10 to the log base 10 of 18 simplify to? 18. 4 to the what? 2 to the x, or we could have just skipped to saying log base 4 of 4 to the 2x. And log base 4 of 4 to the 2x is 2x. And that's it. Questions on any of this here? Are we ready for the next one? So let's go on and simplify these here. So log 8 to the log base 8 of x would be x. The next one is log base 7 of 7 to the negative 3x is negative 3x. Now the next one, log base 2 of 64 to the x. Well, it's just, that's not going to be just x. Because we have to rewrite 64 as what? 2 to a power. Now we need to see what power that would be. 8. So we could say 2 to the 8th, and check it here, is 256. So we can say 2 to the 7th is 128. So exactly, 2 to the 6 is 64. So here we would have 2 to the 6, and we'd also have our x. Because we could put 2 to the 6 in parentheses to the x, but we do know powers of powers multiply, so it's the same as saying 2 to the 6x. So how would this simplify now? Let's simplify to 6x. And last but not least for these set here, we have e to the ln of 20. What do y'all think this would simplify to? What is the base for natural logs? E. So what we're saying is that I have e to the ln of e of 20. Well, the base, it would be 20, yes. It's just like with 10 and log base 10, 10 to the log base 10 simplifies out. Here, e to the natural log would simplify out. And this one here, we can actually plug into a calculator. Because we can say second e to the ln of 20 into 20. Some of the others we can't type in because we can't type in the variable x. But if it's just straight numbers, we can. Any questions on any of these here? Now, the only other thing we're looking at today is finding the inverse. Now, as I've already said this once before, exponentials, b to the x, y equals b to the x, its inverse is actually log base b of y is equal to x. These are inverses of each other, and exponential and logarithms are the inverse functions. So if we want to find the inverse, really we're just rewriting these as logarithms, or vice versa. So when we look at this first one here, as we did in the last chapter, the first thing we need to do in finding a logarithm, when they give us the function in the form of f of x, is we need to rewrite f of x as y. What was our next step in finding the inverse? Right, but technically we would need to switch x and y. And exactly, then we can rewrite this as a log. And we would have log base of x because y equals b to the x is equal to log base b of y equals x. So here our b is 6. The exponent is y, so log base b of y equals x, because we switch. Yes. Let's make sure. Yes, so it should be log b y equals x. Sure. No, this is actually right. In this here, because y equals b to the x, yes, is log base b of y equals x. So when we switched it, x and y flip places. Here, in this general setup, we didn't switch the x and y. That's why they're flipped. Does that make sense? Because in terms of y is what we're getting this back to. If I had left y equals 6 to the x, then it would be log base b, so log base 6 of y equals x. But with our inverse, we need to flip the x and y, which would get us to this here. Does that kind of make sense? Any other questions on this here? We ready for the next one? So here, this next one, they were nice enough to already give us y equals. Y equals the natural log of x plus 3. Well, we can switch the x and y. X is equal to ln of y plus 3. Now for this one here, we need to rewrite it from logarithmic to exponential. So we would have e to the x equals y plus 3. Because for our natural logs, I'll write this in the center. ln of x equals y is the same as e to the y equals x when we're switching those places. Any questions on this so far? Now, what do we need to do to get y by itself? We need to, which would tell us that y is equal to e to the x minus 3. Any questions on any of this here so far? Any questions on anything we've done thus far? We good with these here? We ready for these next two here? Now, this is going to jump a little bit out of order, but I don't care. What did we say whenever we had the log, where the base and what's inside the log are the same? They do what? They cancel out, yes? So what would happen if I applied log base 11 to both sides of this function? Well, we would get log base 11 of y is equal to log base 11 of 11 to the x, yes? Now, the log base 11 of y, there's no way that can simplify, yes? Because that's just saying log base 11 of y equals, what is log base 11 of 11 to the x? X, yes? But again, for the inverse, we need to flip our x and y. So we would have that y is equal to log base 11 of x. I'd also flip the sides, but we get this here, yes? Well, wait a minute. What did our general function say? Y equals b to the x if and only if log base b of y is equal to x. Isn't that what we just got? The reason this works is because of this property that log base b of b to the x is just x. So we can use this method of seeing how the numbers switch, or we can apply log base b of b, whatever the base is, to both sides. We'll get the same answer. Questions on this here? Now this one here, so I forgot to switch the x and y. Let's do it first, and then we'll do the similar thing. So here we're saying x is equal to ln of y plus 6. What is the base with natural logs? E. So as we just saw, if I wanted to simplify the ln out, we have to do kind of an odd thing and apply these to give them a base e. So we have e to the ln of y plus 6. What I do to one side, I have to do to the other. Now what that tells me on the left-hand side is that I have e to the x equals, well, e and ln simplify out, leaving me with what? Now we just need to solve for y. By subtracting the 6 from both sides, telling us that y is equal to e to the x minus And that's why I said this property of log base b of b and b to the log base b works so nicely. This is what makes them nice, that they actually do work this way. Any questions on this here? Are you ready for the next one? So what would we need to do to find the inverse of y equals 4 to the x? Well, we can switch the x and y. X equals 4 to the y. Then what can we do? Two different ways we can do it. Because we can do the method of where we just switch into from exponential to logarithmic, which would tell us that we have log base 4 of x equals y. Or we can apply log base 4 to both sides. Which one do we want to do? The log base 4? So if we apply log base 4, so we'd have log base 4 of x is equal to log base 4 of 4 to the y. Well, here the log base 4 of 4 simplifies, leaving us with just y. On the other side, we have log base 4 of x. And that's it. I want to pull up the graphing calculator. And we'll graph both of these here to see that they are inverses and how this works. Close. So, clear this, clear this. So the first function we had was 4 to the x. Graph this function. So this is our graph. Now the inverse, an inverse function, will always mirror itself across the equation y equals x, so this line here. So if log base 4 of x is the inverse, it should be a mirror across this line. We go y equals, down one more. Actually, let's do purple. We can say math and go up to log base 4 of x. And if I hit graph, we do get this here. Now there is a little bit of a restriction because, or we can't really see it, but it does get really close to the y-axis. It'll never actually cross it because what's inside of a logarithm cannot be 0 or negative. It can't be 0 or negative. Now to kind of emphasize that point, because if we said log base 4 of 0 is equal to y, applying the 4 to get it back to an exponential, we're trying to say 4 to what power, not y, 4 to what power is 0? Well, there's no way to get there. Because if y is 0, well, anything to the 0 power except for 0 is 1. If we make y negative, well, that's really just saying 1 over 4 to what value is going to be 0. Well, that's not going to be 0. That's just going to be a very small number. It'll never get to 0. So there's no way for this to be 0. The same thing is true with saying negative 1. There's no way for us to get this to be a negative. Because if the function can't get to 0, there's no way it can get to negatives. So this here, the inverse of an exponential won't cross the y-axis, where the exponential itself won't cross the x-axis. It will have that asymptote. I mean, we can get the exponential to cross the x-axis by minusing 1, but all that's done, and I can show you guys this here, just means it now won't cross the line at where y equals negative 1. It just moved it down 1. So there will always be a line where it won't cross. Questions on this here? Let's look at the last one because I think this is the last problem of the day. We have y equals ln of x minus 5. Now we can use our kind of switching method, or we can apply e. Which one do we want to do? Apply e. Well, we'll need to switch x and y here in a minute, but we can do this first. E to the y is going to stay e to the y. ln and e will simplify each other out, leaving us with, what do we need to do next? Almost, not subtract. Add. Since the 5 is negative, we would add, telling us x is equal to e to the y plus 5. Or really, our inverse function is y is equal to e to the x plus 5. And that's it. Any questions on this here? So this here, parent graphs and logarithmics, this is kind of a way to see graphically that these are inverses of each other. They are mirror images across the line y equals x. So we do have inverses. And that also means, kind of with what we've learned today, that log of 10 is what? Because we're saying log base 10. Because if the base is not written on a logarithm, it's understood to be 10. They simplify each other out. Because what we're really saying is 10 to the first power is what? 10. The other one we have is ln of e. ln of e, what's the base with natural logs? E. So we have ln base e of e, which is, there's a way that I remember it. It actually is 1, because ln of e is 1. But that's all we're doing for today. Now, with how the semester, because again, we're very, very close to wrapping this up. So today we finished up 6.32. Tomorrow and Wednesday are essentially going to be the same lesson, because it's expanding and contracting logarithms using the logarithmic properties. I'm going, essentially, we'll go over the same thing twice. There will not be 2 assignments. The assignments that, there will be 2 assignments listed on the board, but they're the exact same assignment. Going over that, because for some reason we need to go over that twice just to get it so that y'all can understand it, how it works. Thursday, there will be a lesson 6.61. We're starting solving on Thursday. Unfortunately, I won't be here for that, but I will have a video posted with that. It is not difficult. It's a lot of what we did here, using the properties of exponentials and getting them one-to-one and using this here. And then we'll finish up solving next week. We'll go over the review, go over the review, and then test the week after. So to make it so that that we aren't testing too late into that last week, we need to do this here, okay?